hybrid problem. You look at this, immediately you should realize that this has to be done as a hybrid problem. In other words, that guy in the middle, that box in the middle, should be meshed with solid elements. This thing, which looks like a plate, it should be done with shell elements, and these legs must be done with beam elements. Do not model everything with solid elements. That's a substantial reduction of marks. Okay, now it says use all planes of symmetry if applicable. So these ends are clamped and you put 500 pounds, and this is all symmetrically positioned. You can see that. Therefore, what we need to do is model only 1/4 of this entire gadget. Okay? And obviously, I told you most appropriate element means do not use all solids. Solid, shell, beam. Now, I have done in class these problems mostly with a single part. I did it as a single part. However, this can also be done as as an assembly, where I make a part which is just that block in the middle, or 1/4 of it. I make that plate as a part, another part which is just a quarter of it, because I know I'm going to be cutting it, and finally I just do a third part which is just this leg. So it's up to you how you want to do that. In this tutorial, in this video, I will first do it as a single part, and after I've done it, I'm going to come back and repeat the same thing as an assembly, and it's entirely up to you. Okay, good. So let's go ahead and do it as a single part. So we start with a part file. Part, okay. All right, and remember, I decided that to do only 1/4 of the model instead of making the whole thing and then start splitting it with a saw. Okay, so let's do the plate first. On this, well, let's do the block first. Since we're doing the block, obviously we have to go to the part design. There's the part design. On this plane, I will sketch a square, which is let's see now, 1 by 1. That's 1/4 of that big rectangle that you see in the middle, because the whole thing is 2 by 2. So I'm doing 1/4 of it. So that means this is 1 by 1. All right, exit. And I'm going to pad it symmetrically 2 inches up, 2 inches down. 2 inches up, 2 inches down. That means mirror extent, 2 inches, automatically do 2 inches up, 2 inches down. Very good. Now, why don't we go and save this thing, by the way? File, save management, save as. Okay, so desktop, new folder. I'm going to call this thing homework 5. Homework 5. And I'm going to, let's see now, I'm going to call it lab 50, lab 51. Okay. And just so that there is no confusion, I will make this thing as a single part. Single part. Okay, good. Let's go ahead. The part, remember, we follow the strategy in our course. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's your student ID number. And I will call this as, how about, let's see now, I'm going to give it a good name. How about Psi Wu? Psi Wu is a famous criteria in composites. So that's your last name, Psi Wu. Okay? And this is going to be part, I'll call it symmetry used, okay? I will use symmetry. Symmetry used. I'll say, how about one quarter model? Quarter model. Very good. Excellent. Save it in there, and we move on. Now we're going to create 1/4 of that plate. So first of all, we switch to generative shape design because I want to create a surface. On that XY plane, I will sketch again a rectangle, which is this time 2.5 by 2.5, like that. Because the entire plate is 5 by 5, I'm doing 1/4 of it, so this is going to be 2.5 by 2.5. 2.5. Okay, exit. Now, I want to put a surface through this. Okay, so the easiest way for this particular problem, when you have a closed bounded curve, you say to go to not extrude, don't extrude, FIL, fill, FIL. You select it and you say, okay, there we are. However, I want a cut here. So what I can do is that say on this plane, on this surface, the sketch. Why don't the easiest way is to project that surface onto that plane, and here's project. There are other ways of doing it. By all means, go ahead and do it the way you want. And right there, you see this? Right there? And then you say, okay, exit. And if it's bothering you, let me hide this. And now say split. Where's the split? Here's the saw. The split, read this thing carefully. Element to cut is that surface. Cutting element is that thing that you projected. And we obviously want to remove this piece and keep the rest of it. Up to you how you want to do it. So let me bring this thing in the front so that you can see it right here. Okay? Anything that's bothering you, you can hide. For example, these sketches you can hide. This sketch you can hide. Okay? There we are. Now, save it. Then we're going to create the leg. The leg goes from here all the way down by a distance of 5 inches. So why don't we do the following? We say, okay, let's create a point. And there are different ways of doing it. For example, if you know what the coordinate down here is, type it. And I know what it is. Just look at your drawing. That is going to be 2.5 minus 5. So x is 2.5. Okay. Y is 2.5. As I said, there are different ways of doing this. Minus 5. And there is the leg. There is the leg. Okay. Excellent. So let's create a line between this point and that point. There's the leg. And obviously, if you look at 4 of these, put it together, you get the drawing that you see right there. Okay? All right, save it. Let's make everything out of steel because you're told the entire assembly is made out of steel. So metal, steel on the entire part. And we say okay. And we are pretty much done here. So now we're going to go to generative structure analysis. Catia sees a solid object. Immediately it meshes it. Look, it meshed it. Okay? You can make the element smaller, you can make it bigger, you can make it parabolic or linear, etc. So we just leave it the way it is. Okay? All right. Now, this surface, we have to measure with shell elements. So there is the shell element, or what Catia calls octree triangle measure. And the size, okay, no problem. We're not assessing accuracy here. And let's put some thickness on this. So 2D property on this. Now, what is actually the problem statement? It says the thickness is zero point 0.1 inch. And what do I have here? Yeah, 0.1 inch. Just coincidence. We're going to mesh this thing with beam elements. With beam elements, select that. Beam elements are very versatile. Doesn't matter what the size is that much. Why don't I make it 1? Okay, so there's going to be 5 of them through this. Okay. And the cross section, 1D property, it is circular. You're told it is circular. So all you need is you select the radius of that leg. Oh, let's see now. It says here 0.05 inches. Oh, no, wait a minute. 4 legs are circular with radius that. Okay. Yeah, good, good. So 0.05. I think that's very thin. But I'll leave it the way it is. Okay. And because this is circular, there is no cross section. You just, there's no orientation point. You just select it, and there we are. If you look closely, you put a circle there. Okay. All right. You say okay. All right. So what do we save our analysis? File, save management, analysis, save as. Let's see now. Where is that folder? The folder was called Homework 5, Lab 51, single part, and remember what we call this thing? Student ID number 123456789 dash your name Saiwu dash quarter model. Remember, we're doing this thing as a single part. Okay. Excellent. Okay, so what do we know? We know that the bottom of this is clamped. Clamped, don't put it on point. You're going to have a problem. Don't put it on point. Hide the point. Put it on the vertex. You can put it on the point, but then Catia will not see that. Point is not a finite element entity, and it just basically this is going to be flying away. Okay. Now, symmetry. Okay, be careful here. Surface slider on this surface that you cut in the solid and that surface. Excellent. And using these are symmetry for shells. You see that? So you're going to go user defined restraint. Let's uncheck everything. You look at this. It is in the XZ plane. Oh, make sure it's not user. Don't use user. Global. It was user because I don't know. Last week when I did the problem for you, it was user and stays like that. Unfortunately. Okay, so this is in the XZ plane. Does not move in Y, and rotations opposite. Oops, not that one. Opposite. And this side, user-defined restraint, this edge, that lies in the YZ plane, does not move in X. See that? It lies in the YZ plane of global system, does not move in X, rotations opposite. Now, we have a load of 500 pounds on this. If you don't want to lose any marks, don't put 500 pounds there. You took a quarter of that, so you put down 125, right? 125 pounds. Don't convert it into pressure. We ask you to put a low force, you put a force, okay? So 125. Remember, these things don't have part marks on the test. Do it exactly like what we ask you to do. So this, in the direction Z, minus 125, which is a quarter of 500. You can see that, direction is correct. Now, if I run this thing, it will bomb out because this block is not by any means attached to that surface. So we have to create connections. Why don't we first create a connection between the end of this line and the vertex of the shell? So first connection here, I'm going to name these things, okay? So I say I say end of line, end of, okay, end of line, vertex of plate. How about that? Vertex of plate. Okay, so let's be careful here. First component, I don't want to screw this up, so I'm going to hide that surface first. If I want the end of line, I select it, and then I have to go and select the vertex of the of that plate. So bring it in the front, hide the line, try select this point. If you can, just hide the connection. There we are. You see this? Now you can select it. That white dot was sitting there blocking our view. Now this is going to be a rigid connection. When you have a point to a point, it must be rigid. Think about it. Point and a point. Hey, there's no deformation there. It's just a rigid. Okay. Now we can do that now if you want. So this is the one that I created. You see this? This is the one that I created. So why don't we make it rigid? Now rigid, you're not going to see it in face to face. Okay, face to face is not, it's not in face to face. What you need to do, you look at your connection properties here. You see that? The first one is face to face. The second one is, let me make it horizontal so that you can see it better. This is where you have rigid, right there, rigid connection, rigid connection. You click on it, you select that, and you say okay. Nothing fancy happens here. Basically, you have a rigid connection. Now, I also have to connect the edge, the entire block. And there are different ways of doing it. The way I'm doing it for you is the entire block with that surface. Okay, so another connection, I will say block and block slash surface or plate. I call it plate. Okay. First component, it's entirely up to you. You can select the surface or the plate. And for the second component, you can go and select this and the entire block, okay? So you go to the link, select the pad, okay? So where is that? Expand this and select the pad, okay? You could have also done it this face and that face or the plate, this face and the plate, okay? You could have done it that way, but I didn't. Okay, save everything. And we're going to run it. Okay. By the way, if you look at your mesh, before I run it, let me show you the mesh. Right-click Mesh Visualization. You're going to see all of them appearing. These are the solids. These are the shells. And these are the beams. Okay, so let's go ahead and run. Okay. All right. Now, it looks like something, I didn't do something properly. So let's see what happens here. Obviously, this didn't run, so let's check it out. Let's do the deformation. Okay. You see what happens? What happens is that it looks like when I did the block, you see that? I did the block. Remember I went to the pad on it and I did it? Do you remember that? And I went to the surface. Okay, it looks like it doesn't like that. So what I'm going to do instead, I'm going to do the face of this block. I thought it was going to work, but it didn't. The face of the block and that plate, and the face of this block and that plate. So cancel that. We know what the issue is. Okay. Uh, oh, no. I created the connection, but I never actually declared it. That's why it's running away. Never mind, you can do it exactly like I did. It's just that I did not say what kind of a connection it was. You see that? I defined a rigid one, but I forgot to do this. Take back what I said. Okay, this will work. Just deactivate this. And face-to-face connection. Where is the face-to-face connection? Get it. Fastened, right there, fastened. See, I defined my connection, but I didn't say what kind. And then we say, okay, notice that it did put a fastener sign in the middle, okay, and save it and run it. This time it will work. What I said is also going to work between the face and the plate, the other face and the plate, but it's not necessary, as you will see. Let's run it and see what happens. This time the block will move and will carry the plate with it, as it's supposed to. Yes, yes. There we are. Let's change the scale. Right there. Hey, right there. Excellent. And you can animate it, and you can look at the stresses. Of course, not the stresses in the beam, but you can look at the stresses in the block, which is very little, by the way, because it's a very sturdy block. It just moves as pretty much as a rigid body, but there will be stresses in the shell for sure. Right there. Change the rendering here to material shading. There we are. Okay, very little stress in the block. Very bulky. You put a load on it, it kind of moves as a rigid body. This is it's going to carry the shell with it.